Hello everyone, I am Febin Chandy Thomas. Today I talk about fundamentals. What types of things are in fundamentals? We will discuss. What are the foundations in step by steps? First one is Cantor set theory contradictions. These are a multiple size of infinity. They exist at least one set bigger than the universal set. Next one is Hilbert rigor. It finds the algorithm that all general proves for all true statements. Next one is Gödel incompleteness theorem. Is even worse, there exist true statements for which no proof can ever be found, and it is in any mathematical system there will be either be true statements that cannot be proven or false statements that can. Compatibility, search and clean and post found numbers. Turing developed the universal algorithm machines now called a Turing machine. This machine also had tasks it could not be performed. Next, languages and grammars. What are languages? A language is a set of strings is known as languages. In grammar we say it is a set of rules that define what strings are valued members of a language. Next one is rule structure. Rules and structures. Rules consist of three symbols of three types of symbols. First one, and the terminals are symbols that cannot be further expanded. Non-terminals are symbols that are not part of languages alphabets but can be expanded into a larger substrings. Which next one is which represents that empty string. The next rule we have to say assume the alphabet is set A, B is an example grammar. We will say set A, S, B. These are the things where A and B are terminals and S is a non-terminal. Note that rules can be defined by recursively Z. Next one is formal grammars. A grammar is thus the set of generation rules that define the valid strings of the language. And any string that can be generated by grammar is a valid string is the language that any string in the language that is valued can be generated by the grammar. Next one is regular grammars. Regular grammars are the ones the rules have non-terminal on the left and on the right either. Some points are the empty string, a single terminal, a single terminal, and a single non-terminal, and all. These are the examples of regular grammars. We can see. Next one is state machines. They're designed to allow for modeling of transition from one state to another. It consists of states representing the current state of machines that transition between those states. And the transitions define how the machine changes from one state to another. They are usually the condition is under which the machine changes states. Next, finite automata, a particular type of state machine that has no actions to all. Only states and transitions are known as finite automata. The limits of regular language of finite automata. In finite automata, lack of memory, so that you can't have one part of regular language depend on another part. Consist free grammars where we can in CGs, CFGs, the rules that form on where the n is a single non-terminal and w is a some finite strings of strings are non-strings strings of terminals and non-strings in any order. And in regular languages, non-terminals were restricted as they could appear in the rules. They can appear anywhere. These are the examples of CFG. Let's push down automata. In push down automata means that we can now choose transition based not just on input but also based on what the top of the stack. We can in finite automata is the one important way we are now given the stack on which we can store information. This is a work standard of LIFO stack where information gets pushed onto the top pop of the top. Next one, tuning machine. A tape of finite length divided into cells which can contain one character of data. A program which a set of rules that tells us what to do. Our transition between the state will now specify the letter we should read from tape, the letter we should write to the tape, and the direction we should move to the tape. And these are called Turing machines. Turing machine. What we say a head which can read right in the current cell and which can move the tape one cell at a time, left or right, we can use in Turing machine. So, thank you.